Okay, today's lesson would be about number bases. We are going to learn a whole lot on the number bases. We'll be learning about the base in which we count. Now, we should know that the numbers we use for writing or the figures we use for writing all the numbers we know are in base 10. Okay, so for instance, we only need 10 digits. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. These are 10 digits, and these 10 digits can be used to write any known number in the universe. So as there are 10 digits here, this is called base 10 or writing in base 10. Okay, so the usual numbers we use for mathematics and all other related calculations are in base 10. This is also referred to as the decimal base. So base 10 is also known as the decimal base. Now there are some other bases we might be familiar with. One is base 2, or what we call the binary base, and that comprises of only 2 digits, that is 0 and 1. So any number would be written with a combination of 0 and then 1. In other words, we do not have the number 2 in base 2 or in the binary base. So base 2 is usually written with a subscript. Okay, so this would be written as 0 base 2, 1 base 2. Okay, and for any other number, it would have to be converted to base 2. Now, before we go into conversion of numbers into base 2, there are some other numbers that could be written in. There are numbers, all numbers in general can be written in other bases. Let's see, base 3. There is also a base 3, which is also known as the quaternary base. Base 3 is known as the ternary base. Base 4 is known as the quaternary base. Base 5 is known as the quinary base. Base 6 is known as the senary base. Base 7 is the heptennary base. Base 8 is known as the octal base. Base 9 is known as the nonary base. Base 10 is known as the decimal base, which we have already discussed. There's base 11, known as the undecimal base. Base 12 also known as the duodecimal base. And let's skip to base 16, known as the hexadecimal base. Base 20, known as the vigiseminal base. Then we could also say base 13 is tridecimal, base 14 is quadecimal, so on and so forth. Okay, now what we need to keep in mind is that the number of digits is equal to the number of the base. So you realize in base 10, we noted that there are only 10 digits, which are combined to write all other numbers. So we have 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. There are up to 10 figures in base 10. And those 10 figures are used to write all the known numbers we have in the universe. So we have, if you should count, this is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10 figures. Okay, and it's combined to write all the numbers. In base 2, there is 1, 2, only 2 figures. So in base 3, we are going to have 0, 1, 2, 3 figures. In base 4, we are going to have 0, 1, 2, 3. Base 5, 0, 1, 2, 3, 4. Base 6, 0, 1, 2, 3, 4, 5. Base 7, 0, 1, 2, 3, 4, 5, and 6. Base 8, 0, 1, 2, 3, 4, 5, 6, 7. Base 9, 0, 1, 2, 3, 4, 5, 6, 7, 8. Base 10, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. Base 11, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So we use letters to represent double digits. Base 12, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. We are not supposed to have 11 in base 11. Okay, it only ends with 10. So it goes on. Okay, but the fact that I'm using T for 10 and then E for 11 does not mean it is a universally accepted standard. In some textbooks, you would see A representing 10, B representing 11, so on and so forth. So we just use symbols to represent, or alphabets. It could be any symbol of your choice to represent the double digits. We do not have yet in base 10. And with this, we could say so much that, yes.